Welcome. My name is Marilia Hellmeister, and this is the Environmental Impacts and Carbon Offset of Mass Timber Construction, a comparative life cycle assessment study. Life cycle assessment is a technique used to estimate the environmental impacts involved in the creation of goods and processes. A cradle-to-gate whole building life cycle assessment is comprised of four stages: production, construction, use, and end of life. The assessment must be performed following the international standards guidelines. For the present study, the chosen software was the Athena Impact Estimator for buildings. This assessment was based in two different preliminary designs, one for a mass timber building and the other for a steel and concrete conventional building. The buildings were designed for the Northeast region in the US with a life expectancy of 100 years, a total area of 10,000 square meters, 8-story being 6-story residential use and 2-story commercial use. The goal of this assessment was to estimate the impacts of the embodied carbon regarding the construction materials. Therefore, no data for operational energy was included. This present assessment was based in the New York City features of the software. Using the Bill of Materials input tool, the software reads the data and estimates the flow of energy and material and accounts for the resulting impact of those flows. The results presented here are expressed in terms of global warming potential, that is a reference measure in an equivalence basis relative to carbon dioxide and its heat trapping capacity. The total global warming potential of the concrete building is 2 times greater than the mass timber building global warming potential from stages A to C. That means production, construction, use, and disposal. The total global warming potential of the mass timber building is 5 times smaller than the concrete building when considering the benefits beyond the system boundary because of the carbon sequestration benefits of the material, here represented as negative values. The carbon sequestration benefits, or biogenic carbon, accounts for the carbon dioxide removed from the atmosphere and converted into wood. Mass timber building presents less embodied carbon related impacts than a conventional building design due to the property of wood of sequestering and storing carbon, while other materials like concrete are known to emit carbon during the manufacturing process. Sustainable management practices are necessary to ensure enough supply to the growing future demand of mass timber while maintaining forest ecosystems, wildlife habitats, and reducing forests conversion. Finding ways to optimize operational energy usage associated with low carbon construction materials can lead to even greater carbon offset levels.